Okay, so we're going to go through the IXL examples on M.11 and M.12. So I'll go through each of the problems. You guys really have to learn this material because this is the same stuff that's going to be on the SAT. Solving right triangles is a geometry topic, and pre-calculus is not really in the scope of SAT, but a lot of these lessons, the harder versions of these lessons, are from geometry actually. So they are expected that you're able to do these in the SAT. Okay, so the first problem is, if we take a look, I'm asked to write the answer in simplified rational form, not to round. Now, if you look at this triangle, it is a special triangle for us. We see 30. That means we know it's a 30, 60, 90 triangle. And we said we always start on the short side, which is the 60 side. We double to get to the hypotenuse, and we multiply by square root of 3 to get to the long side. Are you guys okay with that? If you need to, you can rotate the triangle. I can't rotate using this. I should use something else. But let's see. If this is 10 square root of 26, the trick is that if we double to go forward, that means we have to go back. So what's the half of 10? 5 square root of 26. If you're not sure, you say 10 square root of 26, and you multiply that by 1/2. So the 10 and the 2 divide out to become 5. The square root always stays the same. Only square roots can affect square roots. And 1/2 is not a square root. And then the third side, just to say it, is we multiply this by square root of 3. So it's 5 square root of 26 times square root of 3. So you could multiply these together. So 20 times 3 is 60. And 6 times 3 is 18. That's going to be 78. 5 square root of 78. Just to write that. They wanted TU. So TU is going to be 5 square root of 26 because it's just half of the hypotenuse. How do we know that? It's a special 30, 60, 90 triangle, so we know the relationship for all three sides. Let's go ahead and write that answer. 5 square root 26. Booyah. Okay, the next question here is another 30, 60, 90 triangle. And we look at it. Since it's a 30, 60, 90 triangle, Mr. Go, how do you know it was 30, 60 so quickly? Because if it's 90 degrees, that's one of my three angles. If the other one is 60, the other one has to be 30 automatically. They gave us 2 square root of 33. Now for 30, 60, 90 triangles, you always go back to the short side. This is our starting point. Start here. This is the easiest side. So we always run back to it. How is the short side and the hypotenuse related? We said it is always half going back and double going forward. We double to go forward, and we half to come back. So half, let's write it. And if we half it, the 2's divide out, and we're left with square root of 33. So this is square root of 33. And to go forward, that's from short to long is multiplied by square root of 3. Square root of 33 times square root of 3. One hint is this is really 3 and 11. 33 is 3 times 11. So we actually have 2 3's here. So we can write 3 square root of 11. That's our simplified form, not decimal. They want us to find side TU. So TU, right? TU was our bottom side, and that's going to be 3 square root of 11. 3 square root of 11. Okay, this problem again is a 30, 60, 90 triangle. So real quick, let me just do it quickly. 60, 90, 8. They want us to find EF, which if you look is actually this side here. So 30, 60, 90. I know the 60 side is the short side. One way to remember that is that 30 degrees opens up to a short side. A small angle means a small side. Okay? Small head means a small brain. So we have to come backwards from the hypotenuse, we know it's going to be half. So that's just going to be 4. Fantastic. Okay, this special triangle is a 45-45. Now, they purposely gave us the harder side. And we said in a easier triangle, it's 1, 1, square root of 2. If this was 3, it would be 3, 3, 3 square root of 2. So we multiply by square root of 2 to go to the hypotenuse. To go backwards, we're going to divide by square root of 2. So 10 divided by square root of 2. They want us to simplify it, so this 10 over square root of 2. We get rid of square roots by multiplying square roots on the bottom. So 10 square root of 2 over 2 cleans up, become 5 square root of 2. Does anyone need me to do more steps? Please let me know. If you're not sure, we multiply the square root to the bottom and the top. And this cleans up to become just 2. And then we can reduce. Five square root of 2. A similar problem. What happens is, since I know the pattern, to go forward, we multiply by square root of 2. To go backwards, we divide. I don't even have to show work there. I can just divide by square root of 2. And that divides out to become 2 square root of 7. Okay, I'm trying to get to the problems that are not right angles anymore. Same idea. To go backwards, that's a square root of 2. So if we get rid of the square root of 2, that's just 7. 30, 60, 90 still. To go to AC, which is the bottom side, that's just 10. Okay, let me show you guys why. So this is a 30, 60, 90 triangle. AC, 10 square root of 3. And the idea is you just have to learn how to do the patterns. So we said this is my short side. How do we get from my short side to my long side? We multiply by square root of 3. To go backwards, we divide by square root of 3. So 10 square root of 3. We said we divide to go back to the short side. That's just a 10. Okay, sorry, I was going a little fast. Let me slow down. You could do sine, cosine, tangent. You could. But what happens is for 30, 60, 90, the goal is to not have to use a calculator. Is to be able to identify which way do we go. Multiply by 2, divide by 2. Multiply by square root of 3, divide by square root of 3. Because they're all related. Now again, let me revisit this 30, 60, 90 triangle. If I call this co, okay, this is double co. And over here, it would just be co square root of 3, whatever number it is. Given a 30, 60, 90 triangle, it's always going to be double to get to the hypotenuse. Now, the reason why we said this was true is because if I draw a triangle that says 60, 60, 60, give me any side you want. Let's say 120. This is 120, this is 120, this is 120, right? Cool, 100, 120, the sides. If I cut this in half, isn't this side now 60? Sorry, I shouldn't have wrote that, but isn't that side 60 now? So the short side is always half of the hypotenuse because I cut the triangle in half. And Pythagorean theorem would say this is 6 square root of 3, no matter what number you pick. And that's why it's a physical restriction. Like that must be true for all 30, 60, 90 triangles. So the easy problems is if they give us this easy side. If I say this is 30, that means this is my short side here. Oops, short. And if the short side is 4, hypotenuse is always going to be double, right? Because remember, this is a full triangle. It's really just half that triangle. And this is 4 square root of 3. So we talk about the process. You always multiply by square root of 3, and you always multiply by 2 to get there. If we can go forward, we can definitely go backwards. In the case on my left, I see they gave me not the short side. So if they don't give you the short side, we have to work backwards from the short side to the short side. always go back to the short side. And we said, since I multiply to get square root of 3 to go long, I divide by square root of 3 to go short. So 10 square root of 3 divided by square root of 3 equals to 10. Now, you might say, Mr. Ko, what's the point of learning this? Mr. Ko, I'm not going to become a math major. But if you understand what the process I'm trying to teach is, if you can go forward logically, how do we go backwards? Okay, and it's not just a skill of just doing math, it's actually just like critical thinking. And the more problems you do, the better of a critical thinker you'll be. You'll walk into a situation, you'll see what the problem is, what your givens are, what your unknowns are, and what are the relationships to solve the problem. A lot of managerial skills here. But honestly, the more you practice, you will naturally be a faster, more critical thinker. Okay, again, looking at this problem, I'm trying to get to the short side, just in general, okay? Now, how do I go from long to short? Do we add a square root of 3 or do we get rid of a square root of 3? To go back to a short, we get rid of it. So that's just going to be 10. Oh, darn it, sorry, clicked it too fast. Same idea here. I guess these were all special right triangles. Oh, that's kind of weird. Okay, now this is a trick question. Not a trick question, but this is a more of a difficult question that we need to do more algebra 1 with. So what would angle C be? If we see angle U is 30, what would angle S be? So S, not C. S, that would have to be 60. Is this a triangle that we've seen before? It is, yay. Let me pause for 1 second, please. Starting recording, be quiet. Okay, so the way we get from the long side back to the short side is we divide by square root of 3. Okay, we divide by square root of 3. So let me write that. I don't know how to divide by square root of 3, so I'm just going to write this and cross my fingers. Right? That is division. Now we remind ourselves, okay, I can't divide 14 and 3, so we just have to simplify by multiplying square root of 3 on the bottom and the top. And this becomes 3 square root of 14 times 3 is 30, 42, over, hey, look, they're just 3's, so 3 comes out. We're left with square root of 42. You might say, oh, Mr. Ko, can I find the square root of 42? It's not going to work because 14 was 2 and 7, and 3 is 3. So you see, there are no pairs here. So it's just square root of 42. Oh, I've been bad. How many guys mistyped the number and hit enter? Yeah, hate that. Okay, I'm going to go ahead and jump to, I'm 64 already. Okay, here we go. So for this problem here, okay, so did they give us 3 bits of information? Did they give us 3 bits of information? They gave me the right angle, 56, and 6. Yes, they gave me 3 bits of information, means I can solve this triangle. So they want us to find this right side, the bottom side, x, z. So fine, I'm gonna draw this triangle again for me. So if you notice, I'm always redrawing the triangle to show my work and also to, get my brain around it. And if I'm trying to study for a test, I have this triangle to refer back to. So my work is already shown. Okay, so I'm trying to find this side here. You can call it A, B, C, call it whatever you want. Some people call it, if this is capital Y, this is little baby y. So let's call it little baby y. So this is my opposite, this is my hypotenuse, and this is my adjacent. Michiko, how'd you do that so easily? Well, if I look at 56, isn't y opposite? Isn't the 6 opposite of the right angle? And adjacent next to 56. So we are asked to solve for this missing side, y. So we are looking for opposite, but we have hypotenuse. Opposite hypotenuse is sine. Oops. So I write sine. you can just skip this step and just write sine of the angle 56 that I was looking at is equal to opposite over hypotenuse. To solve for y is on top already, so I just need to multiply by a 6, because the opposite of divide by 6 is multiply by 6. Multiply by 6 to both sides. Y is equal to 6 sine of 56. So on your calculator, I'm going to type it as I see it because I know how to work this calculator. You should also work on your calculator to make sure you know how to use it. Do not borrow a calculator for a test because you might not know how to use it. Okay, so I'm going to type it 6 times 56 sine equals, and I'm seeing 4.974. I want you guys right now to try it on your calculator to see if you get the same answer. 6 sine 56, you should get 4.974. If you don't, make sure you're in degree mode. This question was asking me for degrees. They gave me 56, that's a degree. So please double check that. If you didn't get that answer, you're either in the wrong mode or you're writing in the numbers in the wrong order. So please let me know. I don't know why I did that. Okay, so they want me to write an answer. So the answer was, come on, where'd it go? Okay, they want me to say the nearest tenth. So I'm going to round up. So it'll be 5.0. Nearest tenth is this guy. But to round up, I need to bump it up. So 9 plus 1 is a 10. So we'll add 5. Cross my fingers. Ah, whew. Gosh, that was tricky. Okay, next problem. Same idea here. I'm going to write down my question. 536, right angle. Is the 5 adjacent, opposite, or hypotenuse? Like, remind yourself that. Is the 5 opposite, adjacent, hypotenuse? It's across the 36. That's going to be opposite for me. They want us to find WY. WY is this side here. That's my side I'm missing. Is that opposite or, sorry, is that adjacent or hypotenuse? It's adjacent. So which sine, cosine, tangent will use opposite, because I know the opposite, and adjacent when I don't know? Isabella, this was your question? Like, I pick one I know and one I don't know. So since I'm picking adjacent because that's the side I want to solve for. Opposite, adjacent, that's tangent. Tangent of 36 is equal to opposite over adjacent. And we'll call that x if you want. Now, we mentioned specifically for these types of problems, if you have a variable on the bottom, we just do a quick swap. You could do the algebra to flip it, but I'm just doing a quick swap. Just on the side, I'm going to show you guys how I did that. Tan 36 equals to 5 over x. I'm going to multiply x to both sides. X is now on top. And then I'm going to divide the tangent over. Okay, or just do the swap. Oops. Some of you guys are working in a tight environment. I am literally working in a square the size of a 2.5 by 2.5 square at my house. Okay, this all calculator work. Let's go ahead and take out the calculator. Nope, darn it, sorry. Oh man, I gotta play this game. Go away. Such sophisticated background music. I'm colorblind, so it's hard for me to find the X sometimes. Where's the X? Uh-oh, they got me. That's how I got that Nissan advertisement last time.
It wasn't an advertisement.
Oh, there's the X. Gosh. Go away.
So the problem that I got stuck on, Mister, is the one that you basically just like the one you just solved right now. It's find YZ, and YZ is adjacent, whereas 5 is the opposite, and the
Hmm?
angle is 32, the one that they provided to me.
Okay.
When I try to solve it, I just put 5 tan 32, and I got 3.1. And I did the Pythagorean theorem just to make sure if my answer was correct, but it wasn't because my xy was a 5, and then my yz was a 3, and then my hypotenuse was like a 5.8. So I'm like, wait, I'm doing something wrong. So that's what I messaged you about this morning.
It might have been the round off error. But so if you take a look at what I wrote here, this isn't multiplication, this is division. Okay. So if I type 5 divided by 36 tangent, that gives me the 6.88. Well, rounding up, 6.9. Okay. So if I go back, oh, that was right. This would be 6.9. Yay, I got it right. I think I blinked. Okay, let's continue to do a couple more of these problems. So again, I'm writing it out, and I'm super lazy. They want me to solve for BD, which is this side here. Okay, so given the angle 24, you could come here and say, no, this is 66. You could do that if you want to. I don't need to. They didn't ask me for that, but I could. And in the current homework today, that's what you're going to do. They're going to ask you for all 3 sides and all 3 angles. Okay, let's label the side. This is hypotenuse. Everyone okay with this is my hypotenuse? And then so the question mark is my adjacent. You call that C. So adjacent hypotenuse, that's cosine of 24 degrees, right? Because adjacent and hypotenuse, sa, ka, toa. And I have adjacent, no, looking for adjacent, have hypotenuse. That's adjacent hypotenuse. So I have to use cosine. I don't know why I wrote 240 is equal to adjacent C over hypotenuse 10. Sa, ka, toa, 10 cosine 24 is equal to C. And that's calculator work. Our advertisement. 10. I might have to just buy this app. Oops, make sure you clear it. 10 times 24 cosine equals 9.13, rounding up to 9.1. Just to help you guys see what I'm typing on my calculator, I'm typing 10 times angle first, and then I hit cosine, and cosine will change this angle to some decimal, and then you have to equals to mix everything together.